So in the last section, we looked at one-to-one and inverse functions. And we talked about two examples of some basic one-to-one functions, which was linear equations that are not vertical or horizontal, as well as cubic functions. Now the next one that we're going to talk about that's an example of a one-to-one function is something called an exponential function. Okay, so to start off with, what is an exponential function? An exponential function is something where our variable is in the exponent. So a basic example of an exponential function is f of x equals b raised to the x. We do have a few conditions for b. The first one is b must be greater than 0. It must be a positive number. We also have b cannot equal 1. And that's because if it is equal to 1, well, 1 raised to anything is 1, and so it does nothing fancy. Some key features of exponential functions. The first one we have is the domain of an exponential function is all real numbers. We can plug in anything that we want for x and get something back. In interval notation, this is negative infinity to positive infinity. For the range, we have y must be strictly greater than 0, or in interval notation, 0 to infinity, where we have parentheses around both. This is the first time that we have seen a range where the number has had a parenthesis around it. We have a y-intercept. The y-intercept is always going to be 0, 1. And there are no x-intercepts. Another thing that we're going to introduce is something called an asymptote. An asymptote is a line that we get close to, but we never touch. So think back to when you were in 2nd grade and you were pointing at your friend saying, "I'm not touching you, I'm not touching you, I'm not touching you." That's basically an asymptote. We have two basic graphs when it comes to graphing exponential graphs. The first one is if b is greater than 1. This is going to be an increasing curve. It will look something like this. So notice on the left side, this graph gets closer and closer to the x-axis, but it never actually touches or crosses the x-axis. The other one that we have is if b is a proper fraction, or if b is between 0 and 1, then we have a decreasing curve. And so our graph will look something like this. And again, this graph gets closer and closer to the x-axis, but never actually touches or crosses it. All right, so let's go ahead and look at some examples now. Let's start off with f of x equals 2 to the x. The first thing I'm going to do is make a table. And let's go with values of -2, -1, 0, 1, and 2, so that we get an idea of what this does. So if we have 2 to the -2, remember that negative exponents are our reciprocal exponents. So this is going to be 1 over 2 squared, or 1/4. 2 to the -1 is going to be, again, this is a reciprocal exponent, so we're going to have 1 over 2. 2 to the 0, anything raised to the 0 power is 1. 2 to the 1 is 2. and 2 squared is 4. All right, so let's go ahead and plot these points. So -2 1/4 is going to be 2 to the left and just a little bit above the x-axis. -1 1/2 is going to be 1 to the left and half up. 0 1 is on the y-axis. 1 2 is 1 to the right and 2 up. And 2 4 is 2 to the right and 2 up. And so now if we look at this, we do see our exponential shape. All right, let's try another one. Let's try f of x equals 1/4 to the x. Now when I work with exponentials, if you can get 5 points, that's fantastic. But for most of these, it's going to be really hard because these exponential functions grow exponentially. You may have heard that, growing exponentially. What does that mean? It means it gets big really fast. Same thing with small. It gets small really fast. So when I work with exponentials, I have my basic shape in mind, and I only work with -1, 0, and 1. So if we go ahead and plug in -1, we get 1/4 to the -1. I want to take the reciprocal, so this is equal to 4. 1/4 to the 0. Anything to the 0 power is 1. And 1/4 to the 1 is 1/4. All right, so now if we go ahead and graph this, we get -1 4, 0 1, and 1 1/4. So as you can see, this one does get bigger a lot faster, and it also gets smaller a lot faster. The main thing is when you graph these, make sure that you do not touch or cross the x-axis or veer away from it. Make sure that your graph does not start going up again. It should always be going down. Now, this is the method that I prefer to look at it, but just to let you know, if you see something like f of x equals 4 to the minus x, this is the exact same thing as 1/4 raised to the x. So always take that negative exponent, make it into a fraction to make it a little bit easier. Okay, let's look at a couple more. So we're going to kind of introduce this idea of inverse function. We're not going to look at what the actual function looks like in terms of symbols yet, but we can go ahead and graph it. So let's start off by working with y equals 3 to the x. Again, I'm going to work with -1, 0, and 1. 3 to the -1 is the reciprocal of 3, so we get 1/3. 3 to the 0 is 1, and 3 to the 1 is 3. Now, if we look at the second equation, all I did was flip my variables. So I'm going to flip my variables in my table. So I'm going to flip my columns. I'm going to make 1/3, 1, and 3 for my x values, and -1, 0, 1 for my y values. All right, so let's go ahead and graph this now. I'm going to refer to this as function A. I'm going to refer to this as my graph B. So if we go ahead and graph this, we have -1, 1/3, 0, 1, and 1, 3. Again, we're going to get close to the x-axis on the left. We're going to go relatively quickly on the right. So this is my first graph, or my graph A. If we graph B, we have 1/3, -1, so we're going to go 1/3 to the right and down 1, 1, 0, and 3, 1. Now, just like on our original graph, we get close to the x-axis. This one, we're going to get close to the y-axis. And then increase. Again, because x's and y's switch. So for the first one, we get close to the x-axis. For the second one, we switch our variable. We get close to the y-axis. Again, we do not want to touch, cross, or veer away from the y-axis. We can also go ahead and graph our line y equals x. And depending on how accurate your graph was, you should see some mirror images here. Okay, last one. We have y equals 2 to the minus x. And as I said, I personally don't like this notation. So I'm going to switch it. Instead of having y equals 2 to the negative x, I'm going to take 2 to the -1, which is 1/2. And I'm going to raise it to the x. Either way, it's the same thing. So now, if we go ahead and make a table, again, I'm going to work with -1, 0, and 1. 1/2 to the -1, the reciprocal of 1/2 is 2. 1/2 to the 0, anything to the 0 power is 1. And 1/2 to the 1 is 1/2. This is going to be my graph A. For my graph B, I'm going to flip my columns. So I'm going to let x be 2, 1, and 1/2. And I'm going to let y be -1, 0, and 1. So if we go ahead and plot this now, we get -1, 2, 0, 1, 1, 1/2. Should look something like this. For my other equation, I'm going to change colors just to make it a little bit easier. We have 2, -1, 1, 0, and 1/2, 1. If we graph, we should get something that looks like this. And now if we draw our line y equals x, we should see that it is symmetric. All right, so that takes care of exponential functions. The next section that we're going to talk about is logarithms, which is going to be our official name for the inverse of an exponential. So go ahead, take a quick break, and then I will come back and see you again shortly.